So after this lesson, there should be no reason why you can't do the project, because I'm actually going to go through everything. So really, there absolutely should be no reason for not completing this. Alright, so we'll start. So the first thing, you have the numbers for me for student number 1. So let me just write these down. So firstly, the data. Okay, so what's the first one? U1.
U1 is
minus 6. U2 is minus 9. U3 minus 15. Minus 27. Okay, let me make a bit more space here. Okay. Now please just look. Guys, you don't need to be talking, you just need to be listening. U5, what did you say, sorry? Minus 51. And then lastly, U6?
Minus 99.
Okay, U6 is minus 99. Now, what I tell you first is that these numbers here, actually I'm going to need Excel later, so let me just have that open now. These numbers here, you can get them by using this formula. UN equals A UN minus 1 plus B UN minus 2. And just to put this formula in simpler English maybe, you can say that the term you want is equal to A times the last term plus B times the second last term. So what's the name of this type of sequence? Recursive, of course, yeah. So we can use this fact to find the A and the B, because we can say that, for example here, this minus 15 is equal to A times, now what's the last term? Minus 9 plus B times minus 6. And likewise, we could say, for example, this minus 99 is equal to A times minus 51 plus B times what? Minus 27. So, you're in this following situation. You have minus 9A minus 6B equals minus 15, and minus 51A minus 27B equals minus 99. Now, if I can just borrow a Casio calculator for a moment. Now, of course, it's not necessary for me to show you how to solve this. You've seen these types of problems before. It's just a degree 2 system. You can use elimination, substitution, whatever method you like. So I'll just go straight to the answer here after a moment of calculation. So I get here, here's my first answer, A equals 3 and B equals minus 2. For this assignment, your A and B should be whole numbers like this. If you've got fractions, then immediately you've made a mistake, okay? So far it looks like everything is okay. Also, Joan said, if you don't want to type too much maths, you can include your calculations handwritten on the back, I think. Did you say this? Anyways, whatever you type and don't type, what I have here, of course, you must type. And what I have here, you must type. But notice how my process, I didn't actually write it down here. For your assignment, you should type it, or at the least write it down and put it in the appendix at the back of your assignment, okay? Don't do what I just did and give the answer. Have your work somewhere included. Alright, so we've got the A and B now. So back to my formula. I have un equals a, which I know is now 3, un, 3, yeah, minus 2, un minus 2. So this is very important. What I'm going to do now is go to Excel and make the formula here. So the first term, I'm sorry, what did I say the first term? Minus 6 and minus 9. Minus 6 and minus 9. So, the next term is a. What did I say a was? 3. Times the last term. What's the last term here? Minus 9. Yes? Plus b, which is minus 2, times the second last term, which is 6 here. Yeah? So what answer should I get here? What's the third term? What's the third term?
Minus 15.
So if I get minus 15, this looks good. And I do. And what's after minus 15?
Minus 27.
Yeah. So look, there you go. There are the first 20 terms calculated. And you can see that the first 6 terms match up. So far, so good. In fact, I can put this in a chart if you like. Although I think 20 is too much because it gets a little bit too big. In fact, from looking at this, I think the first 10 might even be enough because it's growing quite fast. What type of chart do you feel would be suitable here? Line's okay, but I think the best type here would be column chart like this. Of course, please don't forget, you need to give it a title and all this, so a title, subtitle, you know, do it better than what I'm doing here. I just want to get the graph down. So you can see my graph, it's kind of flat and then it starts to quickly go negative, very negative. See, it's going down like this. Okay. Right, back to the calculations now. So I've done my table and I've done my graph. Well, actually, I'll pause for a moment just to make sure there's no questions. So let me just leave that up on the screen for a second. Now is a good time for questions if you have questions.
Yes, I have quick
Yes.
one.
Yes,
So
good.
my sequence,
Yes?
I'm probably going to change it now.
Yes.
But the 1, 2, 4, 16, 18, blah, blah,
Yep.
blah. I couldn't even get A with either substitution or elimination. And I don't understand why. Every time I tried to do it, I just got the same numbers.
I would feel like the numbers you have should work. The only thing that might be complicating you is that one of your constants will be 0 in your example. So for example, what? Yeah, but
for both of them.
oh, okay. One of them, yes, should be 0. What did you say the numbers were?
It's on my
2, oh sorry, 1, 2, 4, etc. So for you, I can tell you that your B will be 0 and your A will be 2. That's what you should have gotten.
Okay.
So if it didn't work, maybe there's a small mistake somewhere. But if you want to avoid this problem of the 0 here,
Yeah.
new numbers will not have this 0 here. Both the A and the B should be non-zero whole numbers, which could be positive or negative. Okay, so I think this was causing some problem because it was somehow making this 0 as well. Somehow, I'd have to have a look. But anyways, if you want to completely avoid that, you can just grab new numbers.
Can both A and B be equal to 1?
Yes, they could. Both A and B could equal 1 and they could be the same number, yeah. This is not a problem, yes? Oh, that would be at the end, yes. Yes. Can I do what? Oh, the Excel? Oh, but this is all recorded. I'm going to put the video on Moodle so you can watch it again later to see how I did it, yeah. I'll put the video up right after this class. No, maybe at lunchtime actually. Other questions? Okay. Anything else?
Sorry, the term here, when you went to Excel, this term exactly, what did it help us with?
On Excel, Excel produced the table. Excel produced the first 6 terms, and the extra terms after it. So you can see in Excel I actually have the first 20 terms. That's what I used Excel for, to make the first 20 terms.
That term helped in like doing this, or that term was for another thing? That
Which
one that we
term
used,
now?
Yeah, 3U.
This?
Yeah.
Oh yeah, this is the formula I put into Excel. Excel made the table using this formula. Yeah.
Oh,
Yeah. Okay, we'll continue then. Right. So next in the assignment I tell you, I give you this formula for UN. UN is equal to CEKN. So, what does UN minus 1 equal? Well, that would be CEKN minus 1. And then what would UN minus 2 equal? That would be CEKN minus 2. Make sense? Yep. So I take this answer, this answer, this answer, and substitute it back in here. So now I get CEKN equals 3CEKN minus 1 minus 2 CEKN minus 2. Cool? We're happy? Sorry, I know you're not happy. You understand at least? Yes? Yes, okay. Right, what can I do with the C here? Can I? It's a common factor, so I can cancel the C. So that C, which is in everything, is now gone. Gone, gone, gone. Also, I'll expand these powers here. So now I have EKN equals 3EKN minus K minus 2EKN minus 2.
You mean 2K?
Yes, thank you. 2K. Somebody says no. Okay, continue. Yeah. Question? So next I'll divide. Anybody have any ideas on what I should divide every term by? E, yes, there'll be an E, but with what power? Kn. So I divide everything by EKN. So what happens when I divide by EKN? What's the rule for division with powers?
Make the base the same.
True, and then subtract the powers, okay? So you see all of these, I'll cross them out, and they go into the power as minus Kn. Now, what happens? Well, you can see that up the top, they cancel, and they cancel. So now I'm left with E0 equals 3E minus K minus 2E minus 2K. Now I should multiply everything by a term. Does anybody know what term I could multiply everything by? Any ideas?
Substitute e to the power of negative k with a.
We could do that. I'll do something before that just to make it a little easier. A multiplication. Any ideas? I'll multiply everything by E2K. 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 So when I multiply by a term, what do I do to the power? Add to the power. So this will be gone, and this will be 0 plus 2k. This will be gone, and this will be plus 2k. And this will be gone, and this will be plus 2k. So now I have E2k equals 3ek minus 2e0. What's e power 0? 1. So now I have E2k minus 3ek plus 2 equals 0. And now you're thinking, I recognize this. You've seen something like this before, haven't you? So this is EK squared minus 3ek plus 2 equal 0. What type of equation is this? Quadratic. Good old reliable quadratic. ek equals minus b plus or minus the square root of b squared minus 4ac all over 2a. I recommend using the quadratic formula because I think for most people you'll have decimal roots. It just so happens in my example it's quite convenient because my roots actually aren't decimal, but that is unusual. I think for all of you, your roots will be decimal numbers, not nice whole numbers. So if you got a decimal answer here, that is actually okay. In fact, that's what I was expecting to happen. Okay? B squared minus 4ac. You know the formula I'm using or not? Yeah. Oh, sorry. Yeah, maybe I should be a bit more explicit here. A is 1, B is minus 3, and C is 2. It's a quadratic with the variable as ex. So this is like x squared minus 3x plus 2. Uh-oh, the heck is that?
You times by e2k to get rid of the minus k.
Yes, to make the powers positive. Yeah, that's right.
Okay, so
No, that's not a necessary step. I just did it to make it easier for me.
no, I think it's easier for us because when we find k later on, it's either math error or it's minus.
No, that's not actually a problem. I'll get to that in a moment. Yes. Can I continue here? Yep. Now, here we got ek equals 2 or ek is 1. Sorry. 3 plus 1 is 4 over 2 is 2. 3 minus 1 is 2. 2 over 2 is 1. Now, on to maths error. Yep. I just need to go to the side for one moment. This here, bad. Make teacher sad. What's the problem here?
Minus.
Log of a negative number. Yeah. Also bad. However, this might seem a bit odd, but this one here is actually good. Yeah, who can see why this is okay? Yeah. This one here you can't do, this one here you can't do, but this one here is actually okay because when you use the rule, you end up with log 2. So the point I'm trying to make is, just because there's a minus in the log doesn't immediately mean there's a problem. In fact, this thing I'm doing right now does happen in the exam. Sometimes in the exam you get an answer like this. In the final exam. And you might think, I've made a mistake because I have this and I have this. In fact, you've not made a mistake. These can go together to make this, which is good. Okay? So first things first, having log of a negative number is normally bad, but not always bad, firstly. Now, if you do get a negative number back here, so for example, if you got, let's just say, example 2 or minus 2 as an example. Yes? That is okay, because that means here k equals log 2 and k equals log minus 2. The only problem, look up, dude with the question, look up. The only problem here is this I can put on my calculator, but this one I can't. But that is not a problem. You just need to keep it in this form until later. And later, what will happen is something will cancel the log and it doesn't actually matter anymore, okay? It just means you cannot put a decimal value in. For the same reason here, I cannot put this and this in on my calculator, I need to keep it in this form until I can simplify later and get my answer. This is the logic here. If you get a negative number, this is not a mistake, just keep it as log of that negative number. It will fix itself later. Okay? If you don't want to be dealing with negative numbers, if you're in this mood where you don't like negative numbers make you cry, that is okay. If you get new numbers again today, it'll only be positive. Yeah. So if you really don't want to be dealing with it, get new numbers today. Yes? Yes. Just put your code in again. The list you'll get will be new. Yeah. Yeah? What? All right. Anyways, I got sidetracked. Back to this. So in my example, it's nice and clear. I get k equals log 2 and k equals log 1. I know I can calculate these on my calculator, but I will leave them in this form so that if you have something similar, you can see what to do. Okay. Now here I have two answers. I tell you in the next step you need to use both answers as follows. Un equals C1 E log 2, which is something like, I don't know, 0.7 or something like this, n plus C2 E log 1 n. So these two values are your solutions. Okay, next step is to get C1 and C2. So the way to get C1 and C2 is you can use U1 equals and U2 equals. And what did I say U1 equals? Let me see. Minus 6 and minus 9. So in this example here, what does n equal? So here, what does n equal? What am I saying n is? Yeah, what number? 1. And in this one here, what's n? 2. So let's put this in first, and then we'll put this in second. So firstly we have minus 6 equals C1 E log 2, 1, plus C2 E log 1, 1. And I just go for the side for one moment. Can somebody tell me what does this equal? E log x. X. So e's and logs cancel. So can you see why it doesn't matter if it was negative? Because it's going to cancel with the e anyways. So even if this was negative 2, it doesn't matter. The log is now gone. So minus 6 equals C2C1 plus C2. This is my first equation. Now I'll use this one. And I'll get minus 9 equals C1 E log 2, 2 plus C2 E log 1, 2. Once again, e and log cancel. Sorry, I should also have brackets here. Yeah. So here I get minus 9 equals, what number do I write here?
4.
Very good, 4. 2 squared. Plus 2 C2. Now, same thing has happened. You have two equations with C1 and C2. So now we have 2C1 plus C2 equals minus 6, and 4C1 plus 2C2 equals minus 9. So now I can get C1 equals and C2 equals. Okay, so let me not show the work here, it's not necessary. I wrote something down wrong. Yeah. Is it sorry? Is it minus 6 and minus 9 the first two terms?
Yeah.
Yes.
Yeah.
Yeah. Something wrote down wrong there. Oh wait, I remember what I forgot. Back up here. I forgot to put in my A and B that I just have. Where's it gone? Where's my A and B gone? Oh wait, up here. I forgot to put my A and B in down back in my formula. Here there should have been an A, and here there should have been a B. Ah? Why are you panicking? I forgot to write in A and B. If you look at your page, you can see I had it here. Did I? Or did I?
No, you didn't.
I didn't. Oh, maybe that's why I forgot it.
We have to have our A and B in the formula.
No, actually, it's. Hang on. You're confusing your poor tired teacher.
No, I don't think you need your A and B. You only use your A and B to find.
That's right, I don't need my A and B, so I did a stupid sign mistake somewhere. Please help me find the stupid sign mistake. Minus 6 equals 2 plus 1. Oh, here's my stupid sign mistake. Right here. What's 1 squared? 1 and not 2. Yeah. Here's the mistake right here. That should not be a 2. That should be a 1.
Isn't it 1 times 2?
No, it's 1 squared. Here. E and log cancel. I'm left with 1. So it's 1 squared, which is...
Oh, it's not 1 times 2.
No, it's 1 squared. So that should be 1. So that's actually a 1. Right. So that means that should not be there. And now everything is right in the world. Yeah. Relatively speaking. 2, 1, minus 6, 4, 1, minus 9. Fantastic. C1 is minus 3 over 2. Can I zoom in? Yep, yep. All right. Minus 3 over 2, and the second one here is minus 3. Remember I said A and B need to be whole numbers? C1 and C2 don't need to be, okay? Right, so we're in a good position. Now we have C1, C2, A and B. So you can put all of these together. You end up with this formula. UN equals C1 e power log 2n plus, guys, come on, listen, plus C2 e power log 1 n. Now I can clean this up a little bit because what happens with the e and the log? They cancel. So I have un equals minus 3 over 2. Very good. 2 to the power of n plus minus 3, 1 to the power of n.
So this is how you find any formula, any number you want.
Exactly. This is the key to the project. Now you have this formula, you can use it to find any term in the sequence.
So that's the recursive or the explicit?
This is the explicit. The recursive is what we had at the start.
So, but with that formula, I can find I can do the graph.
Yeah, so now if I go back, so first write down this formula and now go back to my spreadsheet. Can I go through it for a moment? Yeah.
Say it just a second.
Okay.
Can I see the negative?
A and B can be negative, C1 and C2 can be negative, and K can be negative. But if you don't want K to be negative, you can get new numbers from today, from now. Yeah? Okay, back to the spreadsheet. Go. Yeah. Right. Okay, so here is n. I'll write here 1. First term, second, third, fourth, fifth, sixth, seventh, 8, 9, and 10. So if I use this new formula, it should make the same term. So can somebody read the formula to me? What was it? Equals? Okay, minus 3 over 2 times?
2 to the power of n.
Yeah, no, I think in Excel it's something like this. Okay, I think you can also do it like this. 2 power n, which here is 1 for the first term. Okay, and then what's the next part? Plus minus 3 times 1 power n. So what should I get here? But this is recording. Alright. Whatever makes you happy. Thank you for your honesty. Right, so the first term I got is minus 6. If I copy this formula down, do I get the same terms? Get exactly the same terms. Now this is the big advantage with this formula. So for this formula, I could jump to term 21. Watch. And I can still calculate it. Whereas with this formula here, I can't jump to term 21. I have to get there one term at a time. So here I'm at term number 30, eventually. Whereas with the explicit formula, I can jump straight to term 30 and get the same answer. So what we've done is we've produced 2 formulas for the same sequence. We've produced a recursive formula and an explicit formula. This one here is the explicit formula, and then earlier up here, this one here was the recursive formula, and they both make the same sequence. That's the key here.
The new numbers that I get now, they can have whole numbers.
The what?
For the K.
The K?
Yeah.
No, they could be decimal, but at least they'll be positive. You can get log of it, yeah. Oh, which is whole numbers?
I mean for the explicit and the recursive, because some of the sequences...
Here, I'll write it down here. A, B, C1, C2, K. Are you talking about if you get numbers now or the numbers you have in the past?
No.
If you get numbers today, right today, this here will be a whole number. Do you know the symbol for that? It's Z. This here will be a whole number. This one here could be a fraction, positive or negative. This one here could be a fraction, positive or negative. This one here, it could be a fraction, but at least it will be positive. Whereas if you got these numbers earlier in the week, it could be negative, which is not a problem, but if this confuses you, you can get new numbers. You getting new numbers? You want me to pick for you? Which sequence did you get most recently?
The most recent one was 10, 3, 1, 1, 5, 33.
No, I know you think I'm great and all, but I can't actually run this in my head. So when did you get this?
Last night.
Then they will be they will have a positive K value.
I got both K's.
Both K's are positive.
I got something with I.
Yeah, this is what I'm saying. That's because the K was negative. If you want to avoid that, you can get new numbers. It's not necessary. It's not necessary.
How many numbers per day can you get?
Oh no, this is it now. You won't get, the numbers won't change. They won't get any easier. So if you get numbers today or tomorrow, they'll be the same.
What if you don't get any more numbers?
Huh?
Like,
What, you got some error message saying you have reached your limit of numbers?
No, it's
You know?
just, it's blank.
It's blank.
Yeah, I can't even sign in my,
Sign into Moodle or get the numbers?
get the numbers.
Web page might be temporarily down. Don't worry, you haven't been blocked. Just check.
I've only used it 1 or 2
Yeah,
times,
no.
not that many.
Yeah, I didn't add in a little spam box where you have to type in a number
It's all
and
over.
like, please confirm you are not a robot. Okay, if you got those numbers yesterday, go with those numbers.
I'll just show you because I think I have something on it.
Okay. And can I continue with this?
Yeah.
Yeah. So the last part of the assignment was to calculate, hey, look up. The last part was to calculate the sum of the first 10 numbers. Okay? Now what you're going to do is, rather than add both of them together, you should add them separately as 2 separate problems. Because if you look at this sequence here on the left, if I put n equals 1, what is the first term here? It would be minus 3. If I put n equals 2, I'll get minus 6. If I put n equals 3, I'll get minus 12. Here I'll get minus 3. Second term? What would the second term here be? Minus 3. And here? Minus 3. So rather than adding them up together, you should add them up separately, etc., etc. This one is super easy to do. If you add the same number to itself 10 times, what do you get here?
Negative 30.
Negative 30. Right? Although this one is not as easy to do, maybe somebody can spot what type of problem this is on the left.
GP.
It's GP, isn't it? With A equal to minus 3, or equal to 2, and n equal to 10 terms, I said. Yep. So on the left we have A 1 minus or power n over 1 minus or. That's a bit too blurry, is it? Can you see this? Just about? I'll zoom in a bit. That's a 10, sorry. So 1 minus 2 is minus 1. Minus 1 divided by 3 is 3. 3 times 1, okay, 2 power. So on the left I get minus 3069. On the right I get minus 30. So if I add them together, I get...
You have to add them?
Oh yeah, because there's always a... The plus is still here. I've just split them into 2 problems, combine the answers at the end. Yeah? It makes it easier this way, looking at them as 2 separate problems, rather than as 1 problem. So the sum of the first 10 terms is minus 3099. If I go back to Excel for a moment, and just delete the 11 to 30th term. So what should I get if I add these first 10 terms together?
3099.
I should. Boom. That's how you do it. So you can see it took me less than 1 class to do this assignment, although I'm sure so probably more time was spent at home. What E at the end? I was able to cancel the E in the log. E at the end. Oh yeah, that means the sum of the first 10 terms.
I have a question.
Yes.
Now we have 600 words or something.
Yes.
How do we set it up? Do we have our math paper, and then we have our Word format, or are we just writing a nice essay saying what's going on here?
Yeah, basically the format would be, you should just open up with a little bit of an introduction on recursive sequence. So what your teacher wants to see here is that They don't want some big long copy and paste thing from some book or website. Really, it can be very simple. The introduction of a recursive sequence, you should explain what it means. You should even give some simple examples so that the reader can understand what is meant by recursive sequence. It doesn't need to be fancy, just needs to be clear, and so that when your teacher reads it, your teacher goes, yes, they know what a recursive sequence is, they've explained it well, they understand the context of this assignment. What you didn't see here in my answer, oh no, just chill, don't pack up now, you're looking very, very highly energetic now, just relax, okay, you'll be free shortly. What you didn't see here, and we're giving you valuable information on your assignment due next week on Wednesday, so listen carefully. What you didn't see here is that as you're doing the assignment, your word count will increase because each section requires a lead-in. So for example, like at the end here, you would have to say, to calculate the sum of the first 10 terms, I split my problem into two simpler problems. The problem on the left, or the first problem, is a simple geometric progression problem. And the problem on the right is an even simpler problem of adding the same number to itself 10 times. You know, and you'd be surprised, but very, very quickly you'll reach the word count. The word count is not going to be a problem. Really, it's not. You think it might be, but when you actually start typing the steps and the explanations, you'll very quickly reach the word count. So firstly, word count is not a problem. Now, you should type maths, but if you're finding it difficult to type all of the maths, what you could do is include your workings and calculations on a handwritten page and put it at the back. But please, if you do that, you should have some kind of reference system, like a 1, a 2, and a 3, so that you can do something like this. In your report, you can say, I have produced two linear equations of A and B. Here they are. I have solved these equations. To see how to solve them, go to the appendix part 1. The answers are, and then give the answers, okay? So you have to type the key steps, the answers and the questions, but the workings can be done on paper neatly and attached to the back. Although it is better if you can type it. If it's causing you too much trouble, you can do this. Yeah? Yeah? Question?
Yeah,
Yeah.
I said you have to put DB numbers.
No. The number was just to generate a sequence, that's all. So you can just say my sequence is. You don't need to say your number.
DB number.
Oh, the DB number goes on the front of all your assignments that need to be submitted. If you don't have it yet, you need to ask your tutor if they have it. Your tutor might have your DB number, they can give it to you. If your tutor doesn't have it, then just make sure you write your name clearly on it so that we know who to give the A star to. Yeah? Okay, any other questions about it? Yes? I want me to check something, and you want me to check something, and you want me to check something. Okay. If you have questions, of course, you can ask me or John, and also you can email me or John in questions as well, alright? Okay.